Okay, it's Mr. Upster, and we're still working on inverse functions. So let's consider this first problem here. Gills participates in a race in which he has to run 10 kilometers, then cycle 30 kilometers. He runs at 20 kilometers per hour and cycles at x kilometers per hour. Show that a function to model his average speed is given by this scenario here. Well, we have to think about what in the world does speed mean. Well, speed, which I'll call s, speed is equal to the total distance, right, over the total time. Well, if I think about that, my total distance in this race is I'm going to do 10 and I'm going to do 30. So I'm going to add 10 plus 30. But I also know that he runs at 20 kilometers per hour for 10 kilometers. So I also have to recognize that time is equal to the distance over the speed. So for my running, for the time to run, the distance is 10, the speed is 20. So the time it takes to run is 1/2. The time that I take to cycle, though, is going to be he cycles for 30 kilometers. The total distance is 30, and the time is x. And so if I add 30 over x here, and so my total distance is 10 and 30 is my kilometers. My total time is a half hour, and this is in hours, and 30 over x, which comes from our relationship between time and distance. Now, what our job is to algebraically come up with this. Well, I have fractions here. One of the things I can do is if I recognize my common denominator of the bottom fraction is 2x. So I'm going to multiply this function times 1. But the 1 is going to look like this. And I've chosen 2x because that's the common denominator. When I do that, I get, this is 40 in total. So in total, I get 80x. Over, when I distribute the 2, I get x. And distribute this 2x to here, and I get plus 60. And there is my s of x, where x is the speed of cycling, and big S is the average speed. And then it says to find the inverse. Well, the inverse switches my x and y value, so I'm going to say that x is equal to 80y over y plus 60. Okay, so then solving for y, I'm going to cross multiply, so I get xy plus 60x is equal to 80y. I'm going to bring the 80y over and the x over, so the y's are on the same side of the equation. Minus y is equal to negative 60x. And I'm going to factor out a y, so I have one single y times x minus 80. And then the next step, I'm going to end up dividing by the x minus 80. So y is negative 60x over x minus 80. And if I want to just get rid of this negative sign, I could also say that 60x is over 80 minus x. Either way is fine, but I must answer the question asked. It's asking for the inverse, so I have to change it to this. If I forget to change the y, I may lose the final point. So now, in the IB world, this word hence means something specific. It means you must use the previous result. There's no choice. We're not asking you to do it differently. You must use this. So when I look at this, I have S inverse x. And I want to find the cycling speed he needs to achieve an average speed of 35. Well, up here, the average speed is s. So that means that x now is the average speed. And previously, the x was the cycling speed. So that means this is the cycling speed. And I want to find the cycling speed when the average is is 35. So that means S inverse of 35. I plug in 35, it's my average speed, is 60 times 35 over the 80 minus 35. And if I crunch that out, I end up with 46.7 kilometers per hour.